Now that we've gotten acquainted with the usage of the SDK to run our quantum algorithms, let's have a look at how we can combine quantum and classical computations using hybrid algorithms. In this module, we will discuss the introduction on hybrid algorithms in the QI platform, how to write a hybrid algorithm, how to run a hybrid algorithm using the SDK, and finally, how to access and modify the results. Hybrid algorithms combine both quantum and classical computation to enhance overall performance. Naturally, some computations are more efficient on classical computers, while others are better suited for quantum processors. With hybrid algorithms, we provide the ability to combine both in a single framework, allowing us to leverage the strength of each paradigm. In simple terms, a hybrid algorithm is an algorithm that alternates between quantum and classical computations in an iterative process. In the diagram below, you can see how traditionally this would look. You would upload your algorithm to the Quantum Inspire platform, and you would run the classical computations on your own side. With hybrid algorithms, this becomes the following. You upload a complete algorithm to the Quantum Inspire platform, and both the classical and quantum parts are executed on the server side. In essence, we've already shown you how to use hybrid algorithms. If you look at the diagram below, what we do here is we upload an algorithm to the Quantum Inspire platform, and we can process the results that we receive back using the SDK. And then we could use those results to modify our algorithm and repeat this process. As you can see, there's communication going on between the QI platform and your local machine. Another way of doing this is the following. We could make the QI platform responsible for taking also the classical computations. This way, we could leverage the resources on the server side. Also, we would not have to iterate every time, but we could wait for a complete job with both the classical computation and the quantum computation to finish. Any hybrid script that will be executed on the Quantum Inspire platform is required to have at least the execute and finalize functions. The execute function is the function that gets called by QI first. As an argument, it gets the quantum interface, which is what allows you to actually execute your circuit. A simple example is shown below. In this example, the same circuit is executed 5 times in a row as a simple illustration of the interchanging control between the hybrid and classical domains. Normally, you might want to change your quantum circuit between each iteration based on your results. The QI hybrid backend is a special backend that is intended for use in hybrid scripts only. This hybrid backend does not actually exist. You will specify which backend to actually use for your execution in a later stage. The memory flag can be added to retrieve individual results for every shot. The finalize function allows you to aggregate your results and add them to the output. You get the freedom to dictate which fields are present in the resulting dictionary, which will be stored as the final result. The only constraint is that the output should be serializable. By default, it takes a list of all measurements as an argument, but through the use of globals, you could also export other data. Next, we'll have a look at how to upload the hybrid algorithm using the CLI. First of all, save the algorithm with a PI extension. This will make sure that the QI platform recognizes it to be a hybrid algorithm. Next, select one of the available backends by listing them using the QI backends list command. Take note of the ID, as this will be used in the next step. Finally, upload the algorithm using the QI files upload command. You should receive a job ID, which can be used in the next step. The results can be retrieved using the CLI by running the QI final results method. It might be the case that the job is not yet finished. In this case, you will be notified on this. If this is not the case, you will see a result as shown below. Remember that the results can be tweaked in your code. We will show you how to do this next. In the execute function, you can make use of intermediate results as shown in the code below. As you can see, we have a method called calculate parameters that takes as input the outcome of an execution. This way you could optimize certain parameters based on results from a previous execution. It's also possible to modify the final result in the finalize method. As you can see below, we've added an extra field to the return, which makes us add some result metadata, which in this case contains an aggregated version of the results. Furthermore, we could use global variables, as shown above, to store data that was retrieved in the execute method. In this case, the execute method populates the process results, which later can be used in the finalize method and returned with the final result. Make sure that the return value of the finalize method is serializable. So in the previous demo, we had a look at how we can leverage the Qiskit Quantum Inspire SDK to run our algorithms against the QI backend. In this demo, we're going to have a look at hybrid algorithms, how to create a hybrid algorithm, and how to upload and run it against our QI backends. So I'm in the same JupyterLab environment as with the previous demo. As you can see, the packages we need are installed. We're going to have a look at this hybrid algorithm that I've copied over. And this algorithm is used to calculate the ground state energy of a hydrogen molecule. So I'm not an expert on this, but as you can see, we are defining the molecule here. We're doing some calculations based on a distance parameter that we input, and we're going to try to get the actual energy out of this. And there are two methods that are important in a hybrid algorithm, and those are the execute and the finalize method. So as you can see, the execute method takes as input a quantum interface, which we use to generate this QI hybrid backend. This QI hybrid backend is not a real backend that lives anywhere or has a location, but it's simply a placeholder that's used so that our backend or our API knows that this is a hybrid algorithm. We're going to show you later how we actually define which backend is used. So as you can see, this execute method, it calculates this energy, and it's provided with this backend. And if we have a look at the code, there's a lot of operations going on, but we can also see that there's this result string that's a global variable that gets populated in this line over here. And since this result string variable is a global, we can later reference it in our finalize method, which we are doing here. So in our finalize method, we're providing measurements, which is simply the list of measurements as received from our API. But we're also adding this result string. And this is very interesting because you get to dynamically tweak what your results look like. So next, let's have a look at how we can upload this algorithm and actually run it. To do this, we're going to need the CLI. So again, I'm going to make sure that I'm logged in. To upload the hybrid algorithm, we're going to go to the folder that I was just in, which is QTech QI SDK demo. We should see the file here. Yeah, it's right here, hydrogen.py. So first of all, before continuing, we're going to make sure that we're logged in. As you can see, I'm already logged in, so I'm going to confirm that. And next, we can start by uploading the file. So to do this, we run the command qi files upload. And then we provide hydrogen.py as input. Before we do this, actually, we need to know which backend to upload to. So I'm going to cancel this command and list all the backends. QI backends list. This gives us a list of backends that we can use. And for this example, again, I'm going to go for the QX emulator. Make sure the status of your backend is not offline, because then it would mean that it would not be scheduled and also not picked up. As you can see, all backend systems are idle right now. And we're going to go with the QX emulator, which has ID 1. So what we will do next is run the command we just had. QI files upload hydrogen.py and provide ID 1 as a backend. Okay, as you can see, a job was created. So what we can do now, we can retrieve the final results for the job. Usually you have to wait for a bit before this finishes, but because this is an emulator, this is done quite fast. So we're going to have a look at the final results. QI final results get. I'm going to provide the ID that we just received. And as you can see, we received some results. So now that we have the results in the CLI, we can also go to the web interface, and we should see a project named hydrogen.py, as you can see here. And if we access the code, we can see that it's the exact same code as defined in our JupyterLab environment. We can also have a look at the job, which has a status completed, and as you can see, algorithm type is hybrid. So that concludes our demo on hybrid algorithms. Let's summarize what we've learned in this video. Hybrid algorithms leverage both quantum and classical computation for enhanced performance. Hybrid algorithms can be written as a Python script comprising the execute and finalize methods. The Quantum Inspire CLI provides tools to upload and execute hybrid algorithms. Intermediate and final results can be processed and modified in your script.